Hello everyone and welcome back to my channel. So today we are going to understand Kubernetes architecture. In the previous video we understood what is Kubernetes and why Kubernetes is important. In this video we are going to understand the architecture and also deep dive into the internal functioning of it. So without wasting any time, let's get started. So Kubernetes comes with a cluster. What is a cluster? Cluster is nothing but a group of one or more physical or virtual machines which provide a platform for managing containers, right? So, the cluster includes two main components: control plane as well as worker nodes. Now, control plane as well as worker nodes both can be one or many, right? One or many virtual machines can be included under control plane as well as worker nodes. Okay, so in an ideal scenario where we require high availability, we will always consider more than one virtual machines in each of these components. Okay, both of them can be one or more group of virtual machines. Now let us try to understand the architecture and different components which involve in each of these two main components. Okay, now let us start with the control plane. So I'll draw a small diagram for your reference over here. Okay, I will be including all the four components within this diagram. Okay. Now, one by one, let us try to understand all of these components. Okay, so the first component over here is a kube API server. So, the component of Kubernetes that exposes the Kubernetes API is nothing but the kube API server. So, it is the entry point through which the external world can communicate. Okay, so the external world communicates with the cluster through this particular API server. Okay, and all the kubectl commands as well. So you must have noticed or you must have heard earlier that we make use of kubectl commands in order to um, execute or say deploy the pods on our cluster. So these kubectl commands as well talk to these kube API server itself in order to execute these commands. It is responsible for orchestrating all the operations within the cluster. Okay. It exposes the Kubernetes API, which is used by users to perform the management operations. Also, the communication that happens within the cluster is carried out by the Kube API server itself. Each of the other components of the control plane talk to Kube API server in order to execute certain functionalities. It helps controllers monitor the state of the cluster and make necessary changes as required. Okay, so controller manager also requires the help of kube API server through which it can communicate with the worker nodes as well. Okay. Now let's try to understand what is HCD. So basically, HCD is a database which stores the information in a key value format. Okay, so HCD is the cluster's database where all the information related to the cluster is stored. It's a highly reliable key value store that holds the desired state of your cluster. For example, if the there is a request for creating a pod, okay, and the pod needs to have a particular image, okay, so that image information is being stored within the HCD in a certain key value format. Okay, it forms the single source of truth for the cluster. Okay, so this is all about HCD. Now let's try to understand scheduler. So scheduler, from the name itself, what do you understand with it is that it basically is involved in the process of scheduling the pods on the nodes. Okay, pods in the sense the containers. Okay, I will explain the concept of pod as well. Okay, so basically, let's consider this as a pod. Okay, so pod is nothing but the smallest unit that is being deployed on a Kubernetes cluster. Okay, so a container is being deployed inside of this particular pod itself. So generally each pod will have a single container, but it can also have multiple containers, but it is a rare case because it happens only in case of sidecar containers. We'll in the upcoming videos we'll understand the concept of sidecar and init containers as well, but for time being just try to understand that a pod is something that can have multiple containers, but generally they have a single container within them. Okay, so this is what a pod is. Now this pod needs to be scheduled on the worker node. So if we only have a single worker node, then of course the scheduler will schedule the pod on that particular single worker node. But if there are multiple worker nodes, then in that case, scheduler will decide as to where the pod will go in which of those um, nodes. It will be scheduled on which of those nodes. Okay. So this is the work of scheduler. It identifies the right node to place the container based on the container's requirements. Now, the container might require a certain amount of CPU as well as memory, right? So, that much requirement must be satisfied by the node, right? So, it will first try to understand the capacity of each of the nodes, and accordingly, if a particular node perfectly satisfies the requirement of the pod, then it is going to just place it on that particular node. Okay, so it places the pods on the nodes based on multiple factors such as taints and tolerations, maybe different policies or constraints as well. Okay, so this is all about scheduler. Okay, in the upcoming lectures we'll study everything in depth. This is related to the architecture, so I'll keep it basic so that you understand everything I speak over here. Now let us try to understand the controller manager. So controller manager constantly runs in the background, checking the current state of the cluster against the desired state of the cluster which is present in the HCD. It will check if this particular container is down. If it is down, then it will notice and work to bring a new one up. Okay, so it makes Kubernetes more resilient as well as self-healing. So it is with the help of controller manager that the feature of self-healing comes into picture. Okay. So this was all about the control plane architecture. Now let us try to understand the worker nodes. Okay. I will be drawing worker node here itself. Okay. So this is my worker node. Now the worker node has got three different components. First one is kubelet. Then we have kube-proxy. And lastly, we have container runtime. Okay. So these are the three main components within the worker node. One by one, let's try to understand these components. So kubelet is an agent that runs on each node in a cluster. It listens for the instructions from the Kube API server and deploys or destroys the containers on the nodes as and when required. Okay, so it constantly listens to the instructions from the Kube API server. Okay, and then executes the operations accordingly. And once it has deleted or created any pod on the worker node, it also gives the information back to the Kube API server so that the Kube API server updates the latest information in the HCD database. Okay, so this is how kubelet is important as it manages everything that happens on the worker node. Communication between the worker nodes are enabled by another component, that is kube-proxy. So kube-proxy is an important component for the networking purpose. So the two pods running on the worker node can connect or communicate with each other with the help of kube-proxy. The IP addresses are allocated to these containers with the help of kube-proxy itself. So kube-proxy ensures that the necessary rules are in place on the worker nodes to allow containers running on them to reach each other. Okay. Then we have container runtime. So container runtime is used for managing the containers. It is responsible for pulling the container images from registries, unpacking and starting the containers from those images, then managing the life cycle of the containers, communicating with the OS kernel to isolate the containers. All of these are done by the container runtime itself. Okay, so this is how the components work. Now let us consider a scenario. If we execute a command kubectl run image name, okay, then in that case it is going to create a pod. But what is going to happen internally? Let us discuss that. So as soon as we execute this command, the first request goes to the Kube API server. Kube API server performs authentication. It tries to verify the identity, okay, with the help of kubeconfig file. It then performs authorization. It verifies whether the right person with the right access is trying to create the pod. Once this is done, the information that is coming from this command goes to the HCD. That is, an object is created within this particular database in a key value format. Okay. Once this is done, we got the desired state, right? Once we get the desired state, scheduler will then assign the pod to the the specific worker node. It will first analyze that which worker node is most suitable for the pod with the given requirements mentioned in the HCD database. So it will find the right node for it, okay, and then it will enter the information related to the node in this particular database. Once this is done, it will send this information to the Kube API server. Kube API server will then send the information related to the pod to the kubelet. Since kubelet is an agent which is constantly listening to the Kube API server, it will get the information. Once it receives the information, it will create the desired pod and then ask the container runtime to create the respective image, to create the respective container of the given image. Once the container runtime receives the information, it pulls the image, it starts the container, it maintains the life cycle of it, and then the container starts running. Once the container is up and running and pod is ready to be deployed, the information is then sent back to the Kube API server through the kubelet. That it reports to the Kube API server that the pod has been in the running state and everything is working fine. Once kube-api server will receive it, it will again update it over here and also it will update it in the database. And when you execute kubectl get pods, you will be able to see the state of that particular pod as running. Okay, so in this way it will work. I have used a simple example over here for a clear understanding. Okay, so I will write all the steps over here, like what all things are going to happen. So the first thing is that the request will go to Kube API server where all the authentication as well as authorization will happen. Then the next step is the HCD one where information regarding the pods will be added to the database, okay, in an object key value format. Okay, once this is done, the scheduler will then identify the suitable node, worker node, based on the CPU or RAM requirements of the pod. Okay, once it identifies, the information will be stored again in the HCD. Once HCD is updated, the command will be passed on to the kubelet. Kubelet will receive the information and then it will ask our container runtime to kindly perform further functioning, that is to start the container. Now once the container is up and running, the information will be reported back to the Kube API server and it will update it in the HCD. and then the status will be from pending to running. Okay, so in this way, all of the steps will be happening. I hope it's clear. And if there are any doubts, you can definitely ask me in the comment section. So, this was all about this particular video. I tried to keep it simple since we are at the beginning. Okay. As an as we proceed further throughout the playlist, the complexity will keep on increasing. Okay. So I hope that this particular lecture was clear enough. And if there are any doubts, you can definitely ask me in the comment section. And thank you for staying till the end and listening me. So thank you so much and have a nice day.